Hello all, I welcome you for this session. Today we are going to see what are the types of problem solving agent. So we already know what is an agent and what is a problem solving agent, how to solve the problems based on the agents. So we have different types of agents based on different application. We can use different kinds of agent for building any machine. So we'll see what are the types: simple reflex agent, model based reflex agent, goal based agent, utility based agent, learning agents, and hierarchical agent. So we'll see one by one what are its types and how it's going to help in building a machine learning models. So first one we'll see what is simple reflex agent. So simple reflex agents, by the name itself we can tell that the process is going to be simple. So same way it is going to respond directly to perceptions. So that means, so whatever action that we are going to program, whatever program you are going to add, so based on that action only it is going to reflect and give us the output. So it will not store any prehistoric memory, that is previous information will not be stored in the memory. So that's why we say it as simple reflex agent. So it works respond directly to current perception using predefined condition action rules without storing any history. So that means it is not going to store any previous information. It is going to act what is the current scenario, based on that it is going to act directly. So they excel in fully observable stable environment. So it is going to be work in a stable environment. So here the environment will not change due to the action. So the environment remains the same, only based on the action we are going to execute the operations. So it does not store any information, and it is not possible to execute or it gives struggle when we work with a dynamic situation due to lack of memory, because we are not going to store any previous information. So that's why it is going to lack in dynamic situation. So these kind of agents can be applied in automation tasks like traffic light control and thermostat systems. So we'll see one by one what are its key application. So if you see the key application of simple reflex agent, so these are the basic machines that can be developed with this kind of an agent, that is simple reflex agent. So one by one: smart thermostat, automated vacuum cleaners, traffic light control, automated doors, vending machines, industrial safety systems. So these are the key applications where we can implement this kind of agents in some of the automation tasks. For example, smart thermostat. So if you take the thermostat, if the temperature of the room is going to be heat, it is going to on, or it is going to be cool, it is going to off. So same way, which can be used for simple automation task where we give exact action and it is going to respond in the stable environment. It does not change the environment, which is dynamic. Okay, so we'll see the advantages. So if you see the advantages, these are very much simple to design and implement, because they are going to directly act upon the rules that we have loaded. So the action will be triggered based on the condition what we give. So next will be low resource consumption. Here the consumption that we are going to use will be less, which is computationally lightweight and requires minimal memory and power, because we are not going to store any previous information. It only need less memory, and this can be made suitable for restricted or embedded environment. Next, ideal for simple automation. So these can be embedded in the machines where the processes are ideal for only the automation, simple automation task. Okay, so these are highly efficient for routine. So wherever we have routine based or daily routine based work na, so in industry automation where we need only on and off, so in that case we can use simple reflex agent. So if you see what are the drawback, so here no memory or learning. So we are not going to store any kind of information in the memory. So only less memory we have, and they have inflexible rules. They only execute pre-programmed static rules. So the rules that we added, so it is static, it works in a static environment, so no option for manual update. So here they require manual updates. So here whenever you want to change, so we need only manually, we cannot update it directly, so anyone have to manually update the changes. So next one, failed in partial observability. And in some cases wherever the observability is partial, so it may fail due to partial observability. Then lack of foresight, so it cannot be planned for long term goals, it can only be planned for short term goals, so which require immediate automation task. So in that case only we can use. So these are the drawbacks of simple reflex agent. So next we'll see what is model based reflex agent. So model based reflex agent maintains an internal representation of the world. So as the name suggests that it is going to be act based on the model that it has. So same way like a model, it is going to maintain an internal representation of the world that tracks aspects not directly observable. So the aspects which are not directly observable, it can only take a note of what is happening in and around the world based on the model. So it will have some set of boundary. So based on the boundary, it is going to guess the what will be the result. So unlike simple reflex agent, they can handle partial observability. So it can handle partial observability by updating the internal model based on new information. So whatever new information is suggested, so based on that it can update their internal model because it is going to handle the partial observability. So these kind of agents are particularly useful in robotics, where they help machine navigate complex environment by tracking previous movement. So this can be used in applications like in robotics, so where the machines navigate complex environment, where the machines is going to face the complex environment, so based on tracking the previous movement. So based on tracking the movements, automatically it can take the decision and act upon. So this is model based reflex agent. So if you see the key application, so autonomous vehicles, robotics, smart home automation, gaming AI, industrial or enterprise automation. So if you are going to have in gaming AI, so how this model based reflex agent can be used. So for suppose in gaming AI, so if you have a game, so in that game you may have different characters. So for different characters you may exhibit different actions. So they will automatically they have the internal representation. So based on the internal representation which they already have some previous information which is stored in memory, so that will be used for taking the action. If the man has to grow, he has to take some food. So in some games it is available. If the man will be short, if the man has been taken the food, he will grow a little bit higher. So this will be example of a model based reflex agent. Based on the internal representation, it is going to take the decision by using the previous information. So this is model based reflex agent. So this will be example for model based reflex agent. So in this advantages, it is going to handle partial observability. So unlike simple reflex agent that only see the current state, so simple reflex agent will see only the current state, but here they use the internal model to keep track of hidden aspects of the world. So whenever they want to keep track, and based on that they are going to take decision. So it is going to handle partial observability. Then context awareness and memory, they maintain a record of previous state and action. So here they are automatically, here we are going to use the previous information for taking the proper decision. So instead of taking immediate action, it is going to take decision based on the previous state and action. It is going to act based on the internal representation. So it has the predictive capability. So they stimulate potential consequences of their action, enabling more informed, optimized decision making. So the result may be known before we process. The result may be uh, optimized while taking the decision. So based on the action that is that depends on the internal representation, so it is going to produce the result with the help of decision making. So next, disadvantages. So disadvantages will be computational intensity, model inaccuracy risk, and data dependency. So what can be the computational intensity? So developing an internal representation for the model is a difficult task. So each and every time, in order to create an internal model and maintaining it, it's very much difficult and challenging. So the computational intensity will be the drawback in model based reflex agent. So model inaccuracy risk. For example, if the internal model representation is different and the action that the agent going to take are different based on the previous information and in and around the world what is happening, if some decisions are based on flawed assumption, so it may be it lead to challenging task. So it is having an inaccuracy risk. So model based agent can have inaccuracy risk. Then data dependencies. So they often require large data set to train the internal model. So in order to train the internal model, so it is going to have large data set, so which can raise privacy and data quality concern. So if we increase the number of data set, the quality will be deferred, right? So this will be the drawback of model based reflex agent. So next we are going to see goal based agent. So as the name suggests that it is going to be related to the goal. So based on the goal, it is going to take the action, and which are going to take the sequence, going to follow the sequence. So which action has to come first, so that sequence order have to be maintained. And these are mainly used for pathfinding, task scheduling, and strategic decision making. So based on the goal, it is going to plan the action, and based on the action, some sequence have to be followed in order to reach the goal. So until we reach the goal, we need to find the path and take the possible action, and we have to check whether the agents have the proper sequence. And these are highly useful in applications like pathfinding, task scheduling, and strategic decision making. So next we'll see key applications. So if we see the key application in goal based agents, it is self-driving cars, robotics automation, gaming AI simulation, healthcare system, virtual assistant, smart home management. So based on the goals, the action going to be taken in sequence order until we reach the goal. So these are the key applications of goal based agent. So next we'll see the advantages. So if we see the advantages, it is flexibility and adaptability, strategic planning, complex problem solving. So these are the advantages. So if we see the flexibility and adaptability, so any action that we take, it should be flexible across the entire system. So these agents can replan and adjust strategies if conditions change. So whenever the condition is going to change, again we are going to replan the actions. Okay, so it can be adaptable to any new situations. So as we can update any changes, so it is adaptable to new situation, any kind of situation. So next, strategic planning. They analyze potential future states and select the best sequence of action. So whenever we are going to choose goal based reaction, so we need to follow the action which are in best sequence in order to reach the goal. So it can be planned for long term goal also. And next we'll see complex problem solving. So these can be applied in environment where we are going to solve the problem which are at complex. So ideal for complex dynamic environment. So wherever we are going to use dynamic environment, we can apply this kind of application which is goal based agent. So it is used in like robotics, navigation, chess playing where multiple steps are needed. So whenever we need multiple steps, we can change the decision accordingly. So these are highly used in complex problem solving. So next we'll see the drawback of goal based agent. So what are the drawback? Disadvantage: complex design and implementation, reliance on accurate model, goal conflict. So first one we'll see one by one. Complex design and implementation. So developing this agent is difficult due to the need of modeling the environment, defining clear goal states. So what may be the drawback here? In defining the clear goal, it is difficult in some kind of situation which are complex. So this can be the one of the disadvantage. So next, reliance on accurate model. So if the environment model or the goal definition is incorrect, if the chosen environment and the goal that we set is totally different, so it may take flawed decisions. So that situation, it is going to take flawed decision. So that will be a challenging task. So this will be the one of the disadvantage. Next, goal conflict. So if the agent has multiple conflicting goals, so if the agent is going to have multiple goals which is going to conflict each other, so the necessity to prioritize them is going to be a challenging task. So which goal have to be followed first? So that will be a difficult task. So these are the disadvantage. So next we'll see what is utility based agents. So utility based agents, it is going to evaluate multiple factors to determine the best course of action. So that means it is going to have multiple factors, decided factors. So in that we need to find the best action. So here they use a utility function that assigns numerical values. So here whenever we are using utility based agent, so it is going to perform some kind of a utility function, and it is going to calculate the values to different outcome. So based on the decision, it is going to give numerical values to different outcomes. So here the problem is we need to select which one will be best. So they select actions that maximize overall benefit. So how they are going to select? They are going to select the action which is showing overall benefit, which are highly benefited and balancing objectives. So they are going to choose the actions based on the overall benefit for the system. So based on the value assigned and which is going to show as the overall benefit, so that will be used for utility based agent. So what are the key applications? Here autonomous system, financial trading, recommendation system, logistic and resource allocation, robotics and gaming. So utility based agent, it is going to have multiple factors. So based on the multiple factors, we are going to assign numeric values to it, and we are going to choose the which action which is going to fit, which is going to give overall benefit. So that one will be chosen for developing the model. So these are applied in these applications like autonomous system, financial trading, recommendation system, logistic and resource allocation, robotics and gaming. So whenever we want to create some logistic rule and we are going to find the resource and how it is going to allotted to the path, so that will be the example for utility based agent. So here if you see the advantage, high flexibility, so it can be flexible across any situation, and ability to handle complex problems. So these are the advantage. So if you see the disadvantage, designing an accurate utility function is a difficult task and it is expensive. So in order to design an accurate utility function, it's a difficult and challenging task, and it is also computationally expensive. So this will be the disadvantage. So next we'll see learning agent. So if you see the learning agent, by the name we can tell it is going to learn in different environments. So yes, exactly. So learning agents improve performance over time. So always the learning agent learns at different experiences. So whenever we get new experience, it tries to adapt based on that environment with new experience. And then they typically consist of 4 components. So usually any learning agent, it is going to have these 4 components. One is performance element, learning element, critique and problem generator. So these are the components which are going to be available in learning agent. So they can handle complex and changing environment through continuous improvement. So as we adapt to new experience, they get new improvement, they get continuous improvement whenever the change has been occurred, and it can solve complex problems also. So this is a learning agent. So next we'll see key applications of learning agent. So if you see the key application of learning agents, we can see it is autonomous vehicles and robotics, healthcare, financial services, game AI, customer service or chatbots, then recommendation system. So in this, the learning agent, the example, so if you take the healthcare, so if the doctor has given the prescription once and the symptoms, so automatically we are going to load that model to the machine. So whenever the patient is given, patient information is added, so whenever he is tested, and based on his previous experience, previous report, and what doctor has given some kind of information related to that disease which is with the patient, so based on that it is going to generate some result, so which is going to be exactly like how the doctors used to give the same kind of report will be provided. So that will be the example of learning agent. So based on any environment, any dynamic environment, any new environment, it is going to give us the uh, good decision based on the new experiences. So this is about learning agent. So we'll see the advantage. So if you see the advantage, whenever it is going to enter into new environment, it is going to improve further with continuous improvement. So the agents become more accurate and efficient without requiring complete retraining. So again, instead of starting from the beginning, it can continue based on the accurate and efficient results. The adaptability. So next advantage is adaptability. So they adjust to new situation and changing environment. So whenever the new situation comes, it is going to act based on the environment that is changed. So whenever new situation comes, so whatever it is, they can adjust to new situation and act based on the changing environment. And then reduced human input. So here the human interruption will be less, because they are going to automate based on the uh, information that is it has learned in the previous experience. So based on the previous experience, automatically it is going to complete the task which are repetitive. So here human interruption is less compared to others. So this will be the advantage of goal based agent. Next we'll see disadvantages. Next we'll see disadvantage. So if we see the disadvantage, it is data dependency and quality issues. So these learning agents, they need large high quality and labeled data sets for training. So in this case we need the labeled data sets, so which are which has high quality and requires large amount of data. So the data dependency problem arises. So in this case, so this will be the drawback. Next, high computational task. So training and running these agents, it requires substantial, expensive and energy intensive computing resources. So highly expensive resources have been used in learning agents. And then risk of bias and ethical issues. So it may have risk of bias. So that means it can perpetuate, amplify societal biases. So it can act based on the societal biases. So that will be the drawback. So this is the disadvantage. Next we'll see hierarchical agent. So here hierarchical agent, they are going to organize the behavior into multiple layers. They are going to divide the responsibilities into multiple layers like CNN. So these higher level agents, they are going to decompose complex tasks. So there will be high level agent, middle agent and a lower level agent. So high level agents takes the complex task and little bit delicate to higher level. So that remaining actions will be given to lower level agent. So this technique improves scalability and how they can manage the complex task across multiple domains. So how the complex tasks are divided into different agents and how they combine finally. So this is hierarchical agent. Next we'll see key applications. So if you see the key application, it is autonomous robotics, industrial automation, manufacturing, smart cities and infrastructure. So if you see autonomous robotics, so it is used for complex tasks where high level agents plan navigation. So mainly it can be used for complex environment where the high level agents plan for navigation. So in autonomous robotics, we divide the what is that, based on the hierarchical agent, we are going to divide the task into multiple agents and finally we are going to combine it. So here higher level agent in autonomous robotics will take the plan of navigation, whereas low level agents will take care like obstacle avoidance and motion control. So how we control the actions, so these will be handled by the lower level agents. In case of industrial automation and manufacturing, it is going to take higher level agents will take care of production lines, predictive maintenance and quality control. So these can be divided based on the high level agents and lower level agent. And then smart cities and infrastructure. So in smart city infrastructure we can see that city wide uh, environment and multi domain system will be taken care of high level agent. Low level agent, it takes control of specific uh, infrastructure elements like traffic light timings and energy distribution. So these can be taken care by the lower level agent. So like this how we divide the different actions based on different agents, and finally it is going to be combined into a single model. So this is hierarchical agent. So we'll see the advantage. Specialization allows agents to focus on specific smaller task. So each agent is going to take care of their own action. So it is for improved efficiency and scalability. Complex workflows can be expanded by adding more specialized agents. So whenever we have complex problems, so that can be divided into multiple agents and the task will be divided to different agents and they act accordingly. And then enhanced decision making. The top down layered approach simplifies complex and it is highly used for long term planning. So this can be highly used for long term planning. So if you see the disadvantage, complexity and management, latency stacking, debugging and traceability issues. So as the layers are added, as we are going to divide different multiple tasks to different agent, as more layers are added, so it becomes harder to manage, harder to process. So it requires complex logic to handle communication delicate tasks. So automatically, if we are going to increase the number of process, automatically in order to combine all the process into a single task, it is a difficult task. So it need a proper communication. So that will be the disadvantage. Next, latency stacking. So here agent invocation create bottlenecks resulting in slower, less efficient processing than single agent setup. That means so it can work in an environment where the tasks are divided to different agents and each agent to process it takes more time and resulting in slower. So each process takes if it is slow, so it is difficult to complete our entire process and combine into a single solution. So it takes more time, so it is less efficient in processing than single agent setups. Then debugging and traceability issues. So when a task is failed, it is difficult to identify which agent in the hierarchy caused the error. So when a task is failed, it is very much difficult to identify which agent in which place or in which agent in which kind of task the problem arises. So it is difficult to find each and every go and check each and every agent. So as we divided the task into multiple agents, now in order to check each and every agent where the problem, where the error is occurred, so it is a difficult task. So that's why they say it is having the traceability issues. So with this we complete the different types of agent. So till now we have seen 6 different types of agent. So first one is simple reflex agent, then model based agent, utility based agent, then goal based agent, learning agent, and hierarchical agent. So these are the types of agent in AI. So later we'll see remaining classes. Thank you.